All right, so today we are going to start talking about the chemistry class that we've been doing. So, um, so, if you ever study chemistry, can you see my screen?
Yes, teacher.
Okay.
Yes, teacher.
So, if you study about chemistry, so we need to learn first what is chemistry and what are you, in chemistry, what are we going to study? Okay. So, first we need to understand first what is chemistry and why do we need to study that. Okay, introduction to chemistry. We learn about everyday chemistry, yeah. So chemistry is you see every day in your life. Okay, so from a if you notice here, from trees, waterfalls, from pharmaceuticals, drugs that you drink when you get sick, from foods and fruits, from electronics, from the like internet, like this is all involves some forms of chemistry. Okay, so this all involves some forms of chemistry. So chemistry is technically, you see chemistry in your everyday life. Sometimes you just don't realize it, but you do see it every day. So for example, if you look at this woman, okay, so this woman is having a book and a pencil, and she study about chemistry. So if you look at the tables, everything that you see there can be described by chemical equations. So, for example, you have this coffee cup over here. Inside the coffee cup, you have what? Coffee. Coffee contains caffeine. Okay. So, for example, here you have a chips over here. Chips contain salt. Salt is sodium chloride, NaCl. For example, you also have a glass of water over here. Water is H2O. Dihydrogen oxide, H2O. For example, you have an iPod. iPod is a battery. Within that battery, we use a material called lithium cobalt oxide. And you have lithium cobalt oxide. For example, she writes with a pencil, right? And a pencil is made out of graphite. Graphite is just a long chain of carbons. For example, there is also an orange over there. Orange contains vitamin C. That's all chemistry. So from this point, you say that chemistry is everywhere. Even right now, if you sit wherever you sit, even at your home, you can pick out something and it's just made out of chemicals. Okay, but sometimes now, can you tell me what is the most thing you hear in Timor Leste when people talk about chemistry? Like chemistry in Timor Leste, I think it's already associated with bad connotation. Like people view chemistry as something that is not good. So, for example, have you heard? Imi palaro na to? You heard about labele hang kimia. Don't eat too much chemical food. Have you ever heard of that? Imi raro na ito.
Yes.
Yes, teacher.
But that doesn't make any sense. That portrays chemistry as something that is bad. Yeah, but no, everything you see is made out of chemistry. There are some chemicals that is harmful for your body, but yes, but there's no such thing as chemistry will there's no such thing as chemistry will harm you. Not all chemicals will harm you. Some, yes. That's why it's very important to be scientifically literate. Yeah, you need to understand, you need to understand at the very least when you talk to people, uh, you sound like an academic person, not like so. Emang bela sekolah makuliah sana, emang dia ane masuk akal tu alas segala. Maybe emang sekolah makuliah sana, emang dia, oh yeah, emang ni sekolah tem sekolah lah masuk akal dah. You know what I mean, right? You cannot just say that. Oh, don't eat chemical food because it's bad for your health. What do you mean? Because if you eat rice, that's also chemistry. You eat more mostarda, that's also chemistry. You eat mantolung egg, that's also chemistry. So are you going to say all of those are not good for your health? Huh? No, right? It doesn't
No.
make any sense.
Yes.
So it's very important to be scientific literate or chemically literate. Yeah. Now the question becomes, what is chemistry? What do you guys think? What is chemistry, Alessandra? What do you think is chemistry is? What is chemistry? Just whatever answer doesn't matter, right or wrong. Sikto, guess what is chemistry? Fafani, what is chemistry? Just guess.
Chemistry, basically it's the study of chemic let me try to basically it's the study of like the what is it the chemicals and like how they function.
Chemicals and how they function. Okay, what about you, Alessandra? What do you think is chemistry?
Chemistry is uh, ex- eh, extractor properties and chains of matter. And
Structure properties
uh, uh, uh,
and
extractor
change.
and chains of matter.
Okay. Chemistry is structure properties and change of matter. So study of chemicals, how they functions, structure properties and change of matter. Yes, this is all correct answers. There is no wrong answers here. But let's dive into a more general definition of what chemistry is. Okay, let's look closely of what chemistry actually is. Okay, now chemistry is a branch of science that study about matter and the changes this it undergo. Okay, so science that study about, our keyword here is what?
Matter.
Matter. You study about matter. Okay, and the changes that matters undergo. So chemistry chemistry is a science that study about matter and how those matter changes. That's what chemistry is technically. Okay, so chemistry is a branch of science that study about matter and the changes that it undergoes. Okay, and the changes, matter and the changes. I think Alessandra mentioned about matter and changes earlier. Okay, so that's the general definition. So, but now my question is, what is matter? Say naman matter. Matter na sir, materia na sir. What is matter? Okay, so basically, so the question becomes, what is matter, right? We'll explore that. So chemistry is what you call the central science. So every aspect of industry is the central of that is chemistry. So for example, in engineering, in ecology, agriculture, botany, biochemistry, astronomy, every science that you see, every natural science, the chemistry is at the center of it. That's why chemistry is what we call it as a central science, including architecture. That's also that you also need chemistry to understand that. That's why you're taking chemistry. All right. Now we need to understand first matter. The question is, what is matter? What is matter? Say naman materia. So matter is anything that occupies space. Okay. So for example, so for example, anything that occupies space. So for example, if you look at the backpack as your space, yeah. For example, yun on your pasta. Okay, what do you usually find in your backpack? Okay, so basically, just imagine this is your space, yeah. Just imagine this is your space. Okay, so what is usually you find in the backpack? Sa naman babay mi tayo pasta lara. What?
book,
Book. Okay.
pencil,
Pencils. What else?
eraser,
Erasers. What else? Imi feto sir babenta po makeup room?
Yeah. Lipstick.
Lipsticks. What else? Maybe
Powder.
food. What?
Powder. Eh?
Powder,
Powder.
yeah. Po sir, yeah. What else?
Perfume.
Perfume, probably. Laptops, probably. What's the last?
Yes.
Now, my question is, all of these occupy some space in the backpack. Los galan? Sa saan sila rin ocupa espacio balu iha pasta ni nilaran? Los to?
Yeah.
So chemistry
Yes.
is, if you define matter is anything that occupies space, so that means everything inside the backpack is matter. Materia ida. Los to?
Yes, teacher.
Now, you take it bigger. Kusi pasta, let's take it out from a house. Bigger, a bigger will be like, let's say now you're going for you consider a house as your space, right? A house. What is inside a house? You have people, occupy some space. You have spoon,
Furniture.
furnitures, anything that inside the house occupies some forms of space. That is also matter. So you go bigger, go to countries. Timor-Leste. That is also, if you consider Timor-Leste as a space, anything that contains the space of Timor-Leste is matter. That includes stones, minerals, or whatever. And then if you consider the globe, the earth, anything in the earth occupies space. Let's get it? So anything that is also matter. If you go bigger, let's say go to a galaxy, with many different galaxy, many different planets. You have Earth, you have Venus. Those are all occupy some form of space. So basically, chemistry is, if you define matter as anything that occupies space, that means chemistry is a science that study about matter. So that means you study about anything, everything. Comprende, no? So you understand what is matter now? Comprende what is matter? Anything
Yes,
Yeah.
that,
teacher.
so basically anything that occupies space is matter. So in chemistry, we learn about that. We learn about how these things occupy space. All right? So in order to understand that, because matter din komplikado terlalu. So matter din kan komplikado los barak los galan. Tidak mungkin we need to some way of classifying those matters. Materi ni oi los galan. So you need to classify it. Before you are studying, you need to classify matter. So matter is classified into, the first classification is physical state of matter. So in physical state, estado físico, it generally classified into three physical states. Solids, okay? So for example, stone, that's a solid, right? A table, that's a solid. What else is a solid? Huh? Give me an example of a matter you see that is a solid.
Chair.
The bricks.
Bricks, tree, yes, those are all solid. What else? Okay, matter can also classify into liquid. For example, water. What else is liquid? Besides water. Water, what else?
Juice.
Juice. What else?
Oil.
Gasoline,
Gasoline. Yeah.
oil.
Oil.
What else? What about gas? Give me an example of gas. The air that you breathe.
Smoke.
Yeah, smoke or the air that you breathe every day. You ola o moris ne kan odara is lo segala aning nebe iha lo ha. The air that you breathe, that's a gas. You cannot see it, but you breathe it. Yes.
Yes, true.
What else? Any other example of gases? Like when you boil water, but you mean on a bay, smoke sign gas to. That's water.
Yeah.
Water
Yes.
vapor. That's also gas. What else? So generally in physical, when you just physically describe matter, it only classifies into solid, liquid, and gas. All right. So any questions so far?
None, teacher.
Okay, now that you already understand physical classification of matter, matter also classifies into substances. We call it pure substance and mixture substance. So basically, either you have a pure or mixture substances. What exactly are those? Pure substances are substances that made out from one element or one type of molecule and have structure that is fixed or constant. Example, graphite. Graphite nene pure substances. Tambah saida, tambah graphite ne halo usa elemento idade. Carbon. It only made out of one element, carbon. That's why it's a pure substance, because it only made out of carbon only and no other things. Okay, that's why we call it pure substances. Or for example, copper. Fusion na beta biasa usa liga nene. That's made out of copper, or the symbol is Cu. There is no other element that used to make this wire or copper wire. That's pure substance. For example, salt. This is only salt. Salt is only made out of salt. For example, it only composed of sodium chloride. There is no other molecules or no other molecules that made together to make salt. That's why it's pure substances. Okay, comprende?
Yes, true.
So a mixture substance is, for example, you have air. Air is a mixture. Why? Because air is comprises of 79% what? 79% nitrogen, 21%
Hydrogen.
oxygen.
Oxygen.
You breathe oxygen. 79% nitrogen, 21% oxygen. That's why it's a mixture. It's not just nitrogen, it's not just oxygen, but it's a mixture of the two. So mixture substances are combination of two or more. It's not just limited to two. Yeah, it can be 3, 4, 5, and more. In variable individuals. For example, ice cream. What do you have in your ice cream? You have milk.
Milk, cream,
Milk is cream. So what else?
Color.
Lactose is
lactose.
there's a milk. Sugar probably.
Mm.
You probably have ice also, water.
Mm.
It's a mixture of different things that makes up ice cream, doesn't it?
Yes, true.
So
Yes,
for
teacher.
example, paint. Paint is also a mixture because it's a mixture of pigment for coloring. There is oil in there also, and etc. What about coffee? Why is coffee a mixture substance? Because you have what? Water,
Water and
coffee,
coffee beans
and
or the
sugar.
sugar.
Probably some milk also. Or probably put whatever else that people usually put in their mixture. Okay, so now you understand. So, for example, you mix water and oil. This is how you see it. Yes? Okay, so now you know what is matter and physical state of matter, and then pure and mixture substances. Okay, any questions so far?
No.
None so far.
Okay, cool. Now we further classified matter. So now you're into a homogeneous and heterogeneous substances. You already know pure and mixture substances. Now we are classifying it into homogeneous and heterogeneous substances. What is a homogeneous mixture? So you have a pure substance and mixture substance, yes? But mixture substance classify further into homogeneous and heterogeneous. So homogeneous mixture is a substance that's said to be homogeneous if all portions of materials are in the same state and have no visible boundaries and are uniform throughout. So for example, you have milk. So milk is a mixture of substances. Rosales said milk nilaran. You probably have water, you probably have lactose, you probably have some for some protein in there. Probably you have some zinc. Rosales? Now my question is, in milk, bahira imere susuben, apakah imibele hare bene man ya parte hene protein ya parte hene zinc ni imibele hare langsung. Can you see it physically? There is a separation between them, yes or no?
No.
You cannot
No.
see it, right? That is why it is a homogeneous mixture. Okay? So for example, coffee. Coffee is a homogeneous mixture. You have coffee in there, Rosalai. You have water. You probably have some sugar. But can you see which part is coffee? Can you see which part is water? Can you see which part is sugar?
No.
No, it's just one coffee. Or caffeine, yeah. We call it caffeine. What about chocolate? What about chocolate? Is it a homogeneous? Yes. Chocolate, you have a cocoa in there. You have sugar. You probably have some other elements as well, right? Probably food coloring. But can you see separately cocoa, sugar, and food coloring in a chocolate?
No.
No. So that's why it is a homogeneous mixture. So homogeneous mixtures are uniform throughout. All right. Now let's study about what about heterogeneous mixture? What is heterogeneous mixture? So heterogeneous mixture, a substance is said to be heterogeneous if the composition of the material is not completely uniform. The homogeneous is completely uniform. This one is not completely uniform. Okay. What are some of the examples of heterogeneous mixture? So for example, if you mix water and oil, can you see water and oil separately?
Yes.
Yes, like you the one you
Yes.
see in the mix. They don't mix it so well unless you add another binding agent into it. Otherwise, it's not mixed so well. What about blue cheese? Cheese like this. So there is a cheese and then there's some blue stuff in there, right? You can see obviously there is separation, distinct separation between them, yes? The
Yes,
blue
sure.
part and the cheese white part. So that's why we call it heterogeneous. What about chocolate chip cookies? Okay, so you
You
have a
can see
dough here and you have a chocolate chip over here. You directly see the chocolate chip and then the cookies themselves. Okay, yung panahanay na nito, ito mo rin mafangal, chocolate chip sa nene.
Yeah, fun
yes.
teacher.
Yeah, it's one of my
Yes.
favorites. All right. Cool. Any questions about homogeneous and heterogeneous mixture?
None, teacher.
Okay, cool. Now that you already understand about, so what have you studied so far? Chemistry is the science that study about matters, right? Matter. And what is matter again? How do you define matter?
Anything that occupies space.
Yes, anything that occupies space is matter. So how do you classify matter? Physical states of matter is solid, liquid, and gas, right?
Yes.
And then after that, you
Yes.
also can classify matter into pure and mixture substances. But under mixture substances, you also have homogeneous and heterogeneous mixture. So far, at the very least, you understand what matter is. Yeah, at the very least, you understand. We were able to classify some matter. Okay, so what are some properties of matter? What are the properties of matter? So, if properties of matter is divided into like physical properties and then chemical properties. Okay, so if you look at the properties of matter, you see that properties of physical properties and properties that is measurable, or a characteristic that can be measured, measurable characteristic. Yeah, chemical properties can be also be measurable, but it's not a characteristic. So for example, if you have a let's say a book, let's say you have a book. Okay, so how will you what is the characteristics of book that you can measure? For example, the book has a mass, right? You can measure the mass of the book, right? What else? You can observe the color of the book. What else? Maybe you can
How
observe
many
the
pages?
thickness of the book. Yes. How thick the book is, number of pages, right? Or for example, if you have water and also man. For example, what characteristics of water can you measure? Volume, maybe, right? What else? Maybe mass, volume, density, yeah, and etc. etc. So physical state of matter is classified into solid, liquid, and gas. So describe how determine molecular arrangement and overall. You also have volume. You also have color observation. That's some of the examples of volume and color are some of the examples of physical properties of matter. Now, what about chemical properties of matter? For example, water and gasoline. Which one is flammable?
Gasoline.
Gasoline.
Gasoline. So gas flammability is a chemical property. So if you describe water, if you want to describe physical properties of water and liquid gasoline, what is their physical properties? Both of them are liquid.
Liquids.
But if you want to classify it by their chemical properties, only gasoline is flammable. Understand?
Yes,
For
sir.
example, another chemical property is, let's say, a metal and rice. Okay, which of the two will experience corrosion? Corrosive. Imagine sa naman corrosive to, corrosion to.
Yes, decay.
Yeah. So basically, where do you see corrosion?
Um,
Metal.
paint,
No,
metal. Oh,
paint is
metal.
not
Oh,
correct. Only metal corrodes, not paint. Paint is
metal.
paint
Oh, metal.
goes off. So metal
Oh,
is have a corrosion, right? But rice, it
yes.
will go bad, but there is no corrosion, right?
Yes.
But both, if
Yeah.
physical properties of both are solid, but only metal experience corrosion. So corrosion is a chemical properties. Okay, so for example, so let's study about what about this. So for example, if you have a water and you put in sugar and you put in stone. Okay, when you put water into sugar and then you stir it, what happens? After sometimes you no longer see the sugar. Lost ka lang?
Yeah.
Lost to?
Yes.
So that means water is reacting with the sugar. So there is a reaction. What about stone? Sabay rin mitaw fato kaya be, imi kero to imni fug mianta mutin temos. O sea, arena fácil. You can still see the stone. Lógica lá?
Yes.
Yes, true.
No reaction. So chemical reactivity, that's a chemical, that is a chemical properties. Now, earlier, Bahira, if you have a sugar, what is sugar? What is physical state of sugar? Solid, liquid, or gas?
Solid.
Solid, right? So when you put it in the water and then you stir it, it turns into what?
A liquid.
A liquid, yeah. It turns into a liquid. So there is a phase transformation. We call it phase transformation. Meaning it's transformed from solid to liquid. Right? So anything that's phase transformation, reactive, corrosion, flammability, those are some examples of chemical properties. Okay, so understand the difference between chemical and physical properties?
Yes, teacher.
Yes, teacher.
Good. Next. Now, physical properties. Now, physical properties also further classify into two categories. We classify it into extensive property and intensive property. Now, extensive property vary with the amount of the substance and include mass, weight, and volume. Okay? In contrast, intensive properties do not depend on the amount. For example, color, melting point, boiling point, electrical conductivity, and etc. Usually, when scientists to determine the identity of substance or identity of matter, they use intensive property. If you want to identify the identity of the substance, where they want to convey information about the substance, they use extensive properties. Okay, that's usually how intensive of but what exactly is extensive properties? What exactly is intensive properties? Let's look at an example, okay? Now, for example, you have, let's say, intensive property. Let's say temperature. Now, for example, you measure the temperature here is 25 degrees Celsius. Okay, you measure it. So what happens if you transfer some of those into another bowl? You separate it. You separate the two. So now the question becomes, does the temperature change with the amount that you separate? Yes or no? Temperatura muda kali.
Yes.
Why? How? How does? Imagina be maliring ida. Ya aqua larang. Imi fui balu ya copo. Apakah temperatura ya copo ha aqua ne beda kah? Huh? Imagine that. Can you visualize that? Temperatura beda kali.
No, I think it's still
No, I
it's the
think
same.
No. Yeah, because it doesn't depend on the
Yeah.
amount.
Yeah.
So the
Yeah.
temperature of that does not depend on the amount. Therefore, making temperature is an intensive property
Intensive.
because the property does not depend on the amount. Okay? So for example, extensive property. For example, you measure the mass. So initially you have this 500 grams. Okay? And then you measure it, you separate the two. What happened to the mass?
Mass is
That will be changed. The original 500 grams, now you divide it into 250 grams each. Or you can divide this to be 300 grams and this one to be 200 grams. Now the property changes. So the property is depending on the amount. So the more amount you have, the higher the mass. The less amount you have, the less the mass. So mass is intensive or extensive? The mass is
Extensive.
extensive properties because it is depending on amount of the substance that you have. So mass is an extensive property. Can you understand what's the difference between intensive and extensive property?
Yes, teacher.
Cool. All right. Okay, so let's study about let's make a summary about matter, how we classified about matter. So so matter is, how do you classify matter again? You have a matter, a physical state of matter, you have solid, liquid, and gas, right? And then matter further classify into pure substance and mixture substance. Under that mixture substance, you have homogeneous and heterogeneous substance. But under that pure substance, you also have pure substance that is element. For example, graphite earlier is made out of one carbon element only, or let's say copper wire. That's made just one element of copper. So, for example, pure substance can be also a compound. For example, salt is just made out of salt. Okay, so that's summary on how we classified about matter. Any questions on this?
None, teacher.
Cool. Okay, units of measurement. Now, when you study about chemistry, you're also doing measurement on the properties, on the properties that you study about, okay? So, chemistry study about matter, right? And each matter has physical and chemical properties, and those properties can be measured. So when you measure something, you need to use units to describe it. Los galay? Pero sukat buat rumah o tenki unidade ida para autos describe suada mo sukat, quantifica, to quantify the properties that you measure, right? So now we'll have to learn about the units of measurement. Now, so for example, for international system, there are 7 base units, yeah? When you call base unit, so SI stands for Système International. International, it was it was done in France, so they use French language to describe that. The SI system. So basically, you have 7 base units. Yeah. For example, if you want to measure the length of something, what in naruk, the unit is length. The unit you use is what? Meter. The symbol of meter is M. If you want to measure the length of something, so karak sukat buat ida niya naruk o usa unidade meter. No salay? Bahira o to sukat buat ida niya toda, if you want to measure the mass of something, you use the unit of kilogram.
Kilogram.
Or the symbol of kg, right? Or if you want to measure time can be measured as hours, minutes, and seconds, right? But international system saying that time should be measured in, the unit for times is seconds, or represented by small letter s. Okay, electrical current, the current of the electricity. Okay, that's also a base unit, yeah? Electric current, that's a base unit. You measure it with, the unit of electrical current is ampere, or unit of A. Now, temperature, that's also a unit we use. The unit we use to measure temperature is Kelvin, or the symbol K. The amount of substance, how much amount do you have? Amount of substance is measured by a mole. Mole, yeah? Luminous intensity or candela, that's the intensity of the luminous. So who knows what is can you give me what is a luminous intensity? Someone can say to me a luminous intensity.
How bright it is?
Yes, how bright it is. So for example, when you drive a car with lower lamp or high lamp, that's different luminous intensity. and that intensity can be measured, and the unit to represent that intensity is candela or CD. But there are other almost SI units, pseudo SI units. So for example, if you measure the volume of something, you use liter. If you want to measure mass, no, but not really. Yeah, atomic mass, they use a atomic mass unit or AMU, using the symbol U. So those are 7 base units in the international system. Yeah. So there are also prefixes that we use in the SI system. So for example, if you have peta, that represents 10 to the 15. If you have tetra, that means 10 to the 12. If you have giga, that's you have heard about gigabytes, right? You've heard about megabytes.
Yes.
So mega simply means 10 to the 6. So if I say megabytes, so that simply means 1 times 10 to 6 bytes is equal to 1 megabytes. So this is the prefix is mega over here because you have 10 to the 6 over there. That's why that's a prefix. So if you have kilo, that's 10. So if I say 1 kilogram, so that simply means what? You have 1 times 10 to the 3 gram. Our prefix here is kilo. Comprende?
Yes, sir.
That's what your prefix. So giga, so prefix deci, centi, okay, milli, macro, nano, pico, femto, okay? Okay, now you already know the derived units. Okay, so you study about base units. Base units is what? The SI units, Rosala. How many base units do you have? 7. Seven, right? So for example, consider this box over here. How do you measure this box? For example, you can measure the length of this. What is the unit for measuring the length of something? You use
Meter.
meter. What about if you want to measure the width of that box? What unit do you use? Also?
Also meters.
Also meter. What about if you wanted to measure the height of that? What unit do you use? Also meter.
Also meters, yeah.
So if you want to calculate the volume of a box, it's simply the length times the width times the height. So therefore, meter times meter times meter. What do you have? Meter cubic. Meter cubic is the volume, that's the unit for volume. So meter cubic is a base units or derived units. Meter cubic is a derived unit because it is derived from meter, meter, meter. That's why it is a derived unit and not base unit. So units for volume is a derived unit. Comprende?
Yes, sir.
Understand the difference between base units and derived units? So base units is only 7. Yeah, derived units can be many, many units. Yeah. So volume is, the units for volume is derived units, which is meter cubic. Right? Okay. Well, let's understand what is the difference between mass and weight. Or let's study about weight. Yeah. So Bahira ini emahusi ini niya todang. But usually when people ask you, what is your weight? What is your answer? Baba ini hatang seda. Alessandra.
100 60 centimeter.
Weight. I'm asking about
Oh.
weight.
55.
55 what? Kilo?
Kilogram.
Yes, 55 kilogram. What about you, Favanu? When people ask you what is your weight, what do you answer?
60 kilograms.
Now, do you think that's a correct answer or wrong answer?
It's the correct answer.
Alessandra, what about you? Is that a correct answer?
Yeah.
It's wrong, actually, because you use different wrong units. I don't ask about your mass. I ask about what?
Weight.
Oh, the
Weight.
weight.
Yes, weight and mass is different. Weight is equal to the mass that you have multiplied by gravity. Okay, so for example, Favanu, you have a mass of what? Mass 60 kilograms, right?
Yeah.
So your weight should be 60 kilogram multiplied by 9.81 meters per second square. That is your weight. Or just make it 10 only to make it simpler. So that's the gravity at 10 meters per second square. So that will be 600 Newton. Your correct answer should be 600 Newton, not 60 kilogram. Now, if I ask Virginia, what is your mass? Then your answer is? Huh?
The mass 60 kilograms.
Yes.
That's the
Yes. Favani, what is your mass? Oh, my mass is 60 kilogram. But when I ask Favani, what is your weight? Oh, my weight is 600 Newton. Now, that is something that is always misconception in society. People often misuse things, yeah? So it's good to know the difference between the weight. Comprende to? Difference between mass and weight.
yes, true.
Yes.
So if you talk about the mass only, so this is a, if you see over here, yeah, the mass of the sun is about log kilograms, so that means 10 to the 30, very very big. The earth is about 10 to 24 kilograms. Okay, 1 times 10 to 24. For example, a human mass is about what? It's about, this is 5 kilograms, that is about 2. Yeah. So that will be about 10 to, yeah, that will be between 10 to the 2, right? 100 kilo or between 100 to 200 kilo, right? So from 40 kilo to, let's say, 100 kilos, so 10 to the 2, right? So kilo, that's human mass, correct? So that's human is
Yes.
around in this region. Now, when you study about chemistry, you study about the mass of electrons. That is 10 to negative 5. That will be equal to 0.0000005 kilogram, or equals to 1, which is very, very small. Or sometimes, for example, the mass of an electron is 1 times 10 to negative 30. That will be 0.000000000 to 30 zeros and then 1 kilogram. How small do you think that is? It's very, very small, yeah? Correct?
Yes.
You cannot see it. So when you study about chemistry, you study about mass that have the weight from the very, very small mass to about human size product mass, yeah? to about this region. That's the chemistry. So when you study about chemistry, usually you study about matter that has a mass in this region. Okay, so you study about protons, electrons, molecules, elements. Those are the mass that you will be studying. You will not study about the earth or the sun. So no, you will not study matter in that scale. All right, so comprende, yeah?
Yes, true.
Okay. What about the length? Length. So for example, if you have the length of an adult, it's about in this region, Rosala. It's about 10 to what? 10 to it's about 50, 160 meter. So usually 1 meter, 1.5 meter, 2 meters, Rosala. That's about here. That's for humans of an adult. The thickness of the paper is about this meter. Yeah, this thickness of the paper is about 1 times 10 to negative 4 meter. That will be 0.0001 meter. That is the paper. Suratahan ini thickness. No salah? So the size of a virus ito niya name, that's about 10 to negative 6, I think. That's the size of a virus. For example, flu virus. Namanya apa? Imi ko hetan flu ni imi labe. Imi la senti, imi la hare ni flu ni mais neve mabe. Imi experience it. Losta? So you just experience. So it's a very, very small size or length of the virus. So for example, the radius of a hydrogen atom is about this. The radius of a hydrogen nucleus is 10 to negative 13. So when you study about chemistry, the length of the matter that you study, the matter length that you study in chemistry usually very, very small, yeah, 10 to negative something. So it's a very small size, the very small mass, very small length. So for example, if you study about the length measures the length of atoms and molecules, usually we measure it in angstroms. Angstrom is equal, so 1 angstrom is equal to 10 to negative 10 meters. So if I write 1 angstrom, it simply means 1 times 10 to negative 10. If I write 15 angstrom, that simply means 15 times 10 to negative 10, negative 10 what? Meter, or equals to 100 picometers. All right? Preguntas about length? Any questions?
None, teacher.
Right. What about time? Okay, how fast is the time in a heartbeat, in a second? So for example, you say 1 day is about 10 to the 4th seconds. Okay, unit of time, international unit of time is in seconds, yeah? So usually, sometimes you also, in chemistry, this is the range of time that you will be studying in about 10 to the 8 seconds. Very, very fast seconds. Or very, very slow seconds also. So very, very fast, very, very slow seconds. So that's the time scale that you will be studying in chemistry. Okay, so when you react hydrogen protons and OH hydrogen cation and OH anion, you make water. That is a very fast reaction. That's about 10 to negative 10 seconds. That's very, 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 very small. Very fast, very, very fast. Super fast. Okay, that's the time. Temperature also. So usually when you measure about temperature, so we measure about the Celsius temperature or Fahrenheit Celsius. So usually we will be using this to measure, yeah. Usually in this class we will be using the unit of Celsius and Kelvin. So basically, if you say what is at what temperature does the water boil? You say, oh, it's 100 degrees Celsius. So water boils at 100 degrees Celsius, which is equivalent to 373 Kelvin. What about freezing point? At what temperature is 0 degrees Celsius? What temperature is the water freezes from liquid to solid? That's 0 degrees, which is equivalent to 273 Kelvin. Okay, so those are temperature properties. Right? Pressure. Okay. What is pressure? So who understand what pressure is? Huh? Sama comprende
It's
sa
like
pressure. Huh?
it's like a force,
Yeah, it
like
is
the
a
keeping.
force.
Yeah,
So, for example, you have the same amount of. Suppose you have this box. This is the room. Let's say you fill this room with 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 people. The same room. Now you fill it with more people. Where people cannot even move. Let's call this box 1. Let's call this box 2. So which box is experience higher pressure?
box two.
Box 2. Because you have the same amount of volume, but you have more
More,
substances, more amount. So
yeah,
pressure is indicated by Newton per meter square. Newton is, for example, if of the circle is a person, the weight of the person is what? Newton. The weight each person occupy every meter square of the area. That's why pressure is 1 Newton per meter square. So if you imagine that, yeah, that's why pressure, so 1 Newton per meter square is equivalent to Pascal. Usually we represent it as a Pascal unit. Okay? Understood?
yes,
So this is the region where we will study about the pressure range in chemistry. Right. Okay. So that is it, our class for today.